Hello everyone, thank you for taking the time to watch my video. In this video, you are going to learn about electronegativity. Yes, that's right, we're bringing back electronegativity from our periodic trends unit, but now we're going to use it for the purpose of bonding. We're going to be looking at electronegativity, we're going to be looking at some bonds and be able to see how electronegativity plays a role in this whole topic and idea of bonding. So, let's get started. When we're talking about bonding, the big purpose or the big idea of this lesson is going to be this topic of bond polarity. And when you look at the definition off to the left of bond polarity, it's defined as the separation of electric charge along a bond, leading to a molecule or its chemical groups having an electric dipole. Now we see this term in the definition dipole. We've learned about prefixes di meaning two. We see the word pole. So when we're talking about dipole, we're talking about something that has two poles or a positive and a negative side. And you are probably aware of a couple of things that have a positive and negative side. One being, of course, a magnet, where we have our north pole and our south pole. And as you can see, we've got separation of charges. One side's positive, one side's negative. And we've seen something that also has a north and a south pole, and that is the globe or Earth. We know that the Earth has a north pole generally pointing towards the positive end, and then the Earth also has a south pole, which is generally pointing towards the negative end. So when we're talking about molecules and bonds now, we're going to be looking at the polarity of them and being able to determine whether they have a positive or a negative side. There's three types of bond polarities that we're going to be able to designate. The first one is nonpolar covalent. The second one is polar covalent, and the third one is ionic. So we've been familiarized with covalent and ionic. Now we're going to be able to classify bonds based on electronegativities. Now I like to think of bond polarity and the topic of bonding almost like a tug of war. We know that the electrons are trying to pull the power or the electrons towards them as much as they can, and we're going to see that in this tug of war, one side of that bond might win over another. So when we look at this slide, we see on the top, the top tug of war group, the knot is in the middle. So we don't have one team winning over another. It seems like they are evenly shared. The electrons, that is, are evenly shared on both sides of the bond. When we have an even sharing of electrons on both sides of the bond, we tend to call that a nonpolar covalent bond. There's not one side that's more negative than the other. We have an equally negative side, equally negative bond on both sides. Then on the bottom picture, you can see that the team on the right is actually pulling that flag towards them. So they do have a little bit more strength or more pull towards their side. When you have one side of the bond with more pull than the other, we will call that a polar covalent bond. So the electrons are pulled closer to the atom that has the higher electronegativity. So that is where electronegativity is the key factor in this bond polarity topic that we're discussing, where we have electrons either evenly shared or unevenly shared on one side of the bond. So on that topic of electronegativity, to review from Unit 2 in the periodic trends unit, we were able to study electronegativity and to study its trend across the periodic table, and we have that summarized on the left-hand side of the slide right here. You can see that the metals have lower electronegativities than the non-metals, so we're going to see higher electronegativities towards the right side of the periodic table and lower electronegativities on the left side. Now we're going to be using these electronegativity values, which you can see in the periodic table right here. We're going to be using those values called the Pauling values from the Pauling scale, and we're going to be using those in order to determine if a bond is polar, nonpolar, or ionic. In the table to the right, you can see that we're going to take differences in electronegativities from the bonds to the elements in the bond, and that's going to help us to determine whether or not that tug of war or that electron sharing is being evenly shared or unevenly shared. So we're going to go ahead and look at an example of that where we use the electronegativity values from this chart, and we're going to add that and be able to determine a bond polarity for none other than water. Now, when we look at water, we can see that we have two bonds. We have one hydrogen and oxygen bond, and we have another hydrogen and oxygen bond. So when we're looking at a structure, we're going to want to determine the polarity of all of the bonds within that molecule. It just so happens that in this example, they're the same. So we only need to solve it for one of the bonds. So I'm going to first start off by designating those electronegativity values from the Pauling scale to each of the elements in this molecule. So you can see that a hydrogen has an electronegativity value of 2.1 and an oxygen has an electronegativity value of 3.5. Now, don't be frightened. The examples the chart that we looked at on the left-hand side of this slide right here, you are not going to need to memorize these values. These are values that will be given to you. Again, we're just going to be able to use this and add this to our tool belt in order to apply that to a future assessment in chemistry. So we've added those electronegativity values. Now we want to determine the difference in those values. So I'm going to look at the oxygen and one of those hydrogens. I'm going to take 3.5 and I'm going to subtract 2.1 from that, and I get a value of 1.4. Now, this value is the value that we want to look at for determining bond polarity. So looking at that chart from the previous slide, we want to see where does 1.4 fall in this chart. Well, we see that nonpolar covalent bonds, they need to have an electronegativity difference of 0 to 0.4, and that doesn't fall within that range. So if I look at polar covalent bonds, the polar covalent bond is a bond where the electronegativity differences fall within 0.5 and 2.0. 1.4 does fall within that range. So what I can say is that the bonds in oxygen between oxygen and hydrogen in a water molecule are polar covalent bonds. So all we did was, using some information from a chart, we got some numbers. We used those numbers to do some simple math. We subtracted the bigger number from the smaller number to get a difference. That difference in electronegativity gives us our bond type, depending on what range that value falls in. In this case, oxygen and hydrogen have an electronegativity difference of 1.4. So we looked at that range. We determined that an oxygen to hydrogen bond is polar covalent bond. Now, bond polarity is now going to influence something even greater, which is the overall polarity of this molecule. But before we get to that, we need to really master bond polarity first. So make sure you know from this video that covalent bonds are formed by the sharing of electrons. That is a review from last unit. Some electrons want to pull in electrons more than others. That pulling of electrons, or that tug of war, is called electronegativity. And lastly, an uneven pull towards one end of the bond causes a bond to be polar. Remember that we have positive ends and negative ends. It all comes down to the sharing of those electrons and who's getting more of those electrons within that bond. So I hope that you found this video helpful. You're going to apply this to some practice that I've assigned for you, and we're just going to keep adding to this as we continue on in this chemistry unit. Thanks for watching, guys. I'll talk to you soon.